Here's integrated 3, it's problem 8-113. It says the graph of p of x is shown at right. Use the graph to determine one solution to p of x equals 0. Then use the factor theorem to write a factor of p of x, and read about the factor theorem in the math notes box in this lesson. Well, I can, whether or not I knew the factor theorem, I could certainly see there's an x-intercept here at 2. And I know that where the x-intercept happens, that's where this graph is equal to 0. And that's where this equation also equals 0. So let's look at the factor theorem. Factor theorem says if a polynomial has a root, x equals c, i.e. it makes the equation equal to 0, then x minus c is a factor of p. For example, if you have this cubic, and if p of -1 equals 0, then x plus 1 is a factor. So it's always whatever the root is, but you know how it's like x minus c, so you'd kind of change the sign. So and I wrote some little notes here. So I noted that we have a 0 or an x-intercept at x equals 2. So a factor is going to be x minus 2, and that's what they want you to write for the answer. But also, interestingly, or maybe not so interestingly, this equation, if I just wanted to set it equal to 0, actually this equation, if I plug in 2 for x, that's what would make this equation equal 0. And that shouldn't be super surprising because we saw a picture of the graph and we saw that it equaled 0 at 2. But you could plug in the 2 into the equation, the x cubed, 2 cubed, see how I just plugged it in? And that actually ends up all adding up to 0. So then letter B wants us to determine all factors and roots. So the roots are like the solutions, and the factors are written in factored form, like multiplied together. So a cubic's going to have 3, I want to say in quotes, factors, but maybe they're not all real. It's going to have 3 roots. This one's going to have, we already know what the picture looks like. It's going to have a real root and 2 complex roots. Okay, so I've already written down the factor that I got from the real root. And now these, we don't know what these are yet, but we can use polynomial division to find out, to get a quadratic. And then once we get the quadratic, if it factors, we'll just write the nice factors in there. But I can tell by the graph it's not going to factor, and we're going to end up with using the quadratic formula on it and getting some like things that have I in them. So the first thing to do though is just divide. So we're going to divide. This is polynomial division, otherwise known as polydoku. And when we divide, we make an area model box, and we put the factor we know on the outside here. And then this, I've already filled this in, but the process I took for filling this in is you take the lead term, the highest degree term, and you put it in here in the top left hand box, and then you ask yourself, x times what equals x cubed, and that's where I got the x squared from. So I don't want this to be a whole lesson on how to do polynomial division, but basically once you put this in the top left, then you can get this number, or this term, and then you can use this times the -2 gives you this one, and then this one I didn't know it yet, but I had this -2, and I have that the x squareds have to add up to 4. So that's where that -6 came from. And then once I got the -6, well, The only thing that this could have been is 6, because, 6x times x. And then 6x times negative 2 is negative 12x. And then even though I didn't know what this number was, I looked up at this x and I said, well, negative 12x plus what equals x? And it had to be 13x, and then that forced me to have a 13 up here. And then, because 13 times x is 13x, and then 13 times negative 2 is negative 26. So what this tells me is that this polynomial inside here, those two add up to the 4, those two add up to the 1x, and so what it's saying is that x minus 2 times x squared plus 6x plus 13 equals this cubic. So I can rewrite it as x minus 2 times x squared plus 6x plus 13. That's what that cubic is equal to. I'm kind of boiling it down. So now I've got my quadratic, which isn't going to factor. There's no numbers that multiply to make 13 and add to make 6. So instead of factoring it, I'm going to put it in the quadratic formula. And so I'm going to use 1 for A, and 6 for B, and 13 for C. And then I'm going to, I think right over here I showed all my work of the quadratic formula. So I plugged in all my A, B, and C in the quadratic formula and did all this work. And I ended up with negative 3 plus or minus 2i. But I've been asked to write factors, not roots. Well, I mean, I need roots also, but it said that I had to determine all the factors and roots. So I need to write these in factor form. So basically I'm going to go x minus whatever I have here. So it's going to be x minus negative 3 plus 2i, and x minus negative 3 minus 2i, and then after if I want to clean it up because I don't like all these parentheses, yeah, and actually I don't even have enough parentheses there because I probably should have had another parenthesis, I don't know, out here, right? Anyway, there's more parentheses in there. So I distribute, and so I end up with this. And so this is part of my answer because they asked me to show the factors. So those are the factors, and then the 3 roots that come off of those factors are just zero product property. So if I write x minus 2 equals 0 and I add 2 to both sides, that gives me the 2. And if I say x plus 3 minus 2i equals 0, well, then I'm going to minus 3 on both sides and add 2i, and that gives me basically this, which I already had it. And if I do the same to this, I get this. And if you wanted to just write it, like this, that's fine with me too. But I guess the important part was they wanted you to get the factors and the roots, and they wanted to talk about the factor theorem.